2.2. Analyze conditional statements. This section has a lot of vocabulary in it, so you probably need to take some time and sit down and really memorize these. So the first one is a conditional statement. This is a logical statement that has two parts. A hypothesis and a conclusion. Bad handwriting, I'm sorry. A logical statement that has two parts, a hypothesis and a conclusion. If-then form. If-then form is a form of the conditional statement where the if includes the hypothesis and the then part is the conclusion. Okay, something like if all animals that have wings are birds, then a chicken is a bird. Could you think of anything that might not work? Aha, I can. It's from the dinosaur era. See if you can think of it too. Okay, hypothesis. Hypothesis is the if part. We're kind of re-saying this again from out there, so it's pretty important to know this. Hypothesis is the if part of a conditional statement. Conclusion is the then part of a conditional statement. Okay, the negation. Negation of a statement is the opposite of the original statement. Now, this, because it has a word neg in it, we usually think of this as a negative thing, but it's not really negative, it's just opposite. So if somebody comes up to me and says, we shouldn't have homework on Tuesday, the negation of that would be me saying, yes, we shall have homework on Tuesday. Again, I didn't say a negative sentence. It was just opposite of the one he said. So converse. Converse is a conditional statement that's formed by switching the hypothesis and the conclusion. So if we say, on Tuesdays, we need conditional statements. So hypothesis might be, if today is Tuesday, then I will eat a TV dinner. The converse of that would be, if I am eating a TV dinner, then it's Tuesday. Again, they may or may not be true. So just because you write a converse of a true statement doesn't mean the converse itself is true. Now, you remember that I remember things by making silly stories with them? Converse to me is a type of tennis shoe. So I remember this by how to write the converse is tie your shoes and then run backwards. So switch it around. Okay, inverse. Inverse is negating both the hypothesis and the conclusion. Okay, if it's not Tuesday, then I am not eating a TV dinner. So I'm putting not, or I'm taking not out, doing the opposite of the original statement. Okay, and then contrapositive is formed by writing the converse first, so write it backwards, then negate both. If I am eating a TV dinner, then it's Tuesday, so that's converse. So if I'm not eating a TV dinner, then it's not Tuesday. Okay. I always write these four in order. So I always start with the conditional statement, and then I do the converse. I write it opposite, and then I write the inverse. I go back to the conditional statement and negate them both, and then I write the contrapositive. Go back to the converse and negate both of them. And that's the only way that I can get these in the right order, because I tend to forget them. So even if a test or a homework paper wants me to just do the inverse, I just go to the side and write all four of them and then move the inverse over. Okay, equivalent statements. Equivalent statements are that both true or both false. Okay, you should know now what perpendicular lines are. Two lines that meet in a right angle. Biconditional statement is a statement that contains the words if and only if. You can be in Algebra 2 if and only if you've already taken Algebra 1. Okay, example 1. Rewrite a statement in if-then form. Rewrite the conditional statement in if-then form. All vertebrates have a backbone. First, identify the hypothesis and the conclusion. When you rewrite the statement in if-then form, you may need to reword it so it makes a little sense. So, what's our hypothesis? Okay, the first part would be our hypothesis, all vertebrates. And the second part has to have something about backbones. So, let's throw in some extra words to make this make more sense. We can't just say if vertebrae, then backbone. So we can say if an animal is a vertebrate, remember vertebrate is an animal with a backbone, then it has a backbone. Okay, so this is a conditional statement that we turned into an if-then form. So let's go ahead and rewrite let's talk real fast about the 4 forms of this one, just because we have it written already. So what would be the negation of this? Okay, negation for this is to negate both parts. So we could say for the negation, if an animal is not a vertebrate, then it does not have a backbone. Okay, how about the converse? We're going to put on our shoes and run backwards. So if an animal has a backbone, then it is a vertebrate. Inverse. We're going to negate both the hypothesis and the conclusion. Well, this is again the negation of it, and I've already said that. An animal is not a vertebrate, then it does not have a backbone. So this is the same thing as the negation. How about the contrapositive? Contrapositive, I start with the converse. If an animal has a backbone, then it's a vertebrate, and negate it. If an animal does not have a backbone, then it's not a vertebrate. Whew. Okay. So checkpoint. Look at those 2 checkpoints and write them in if-then form. On number 2, you can just go ahead and say if that, then that. Number 1, you'll have to add a word like shapes or figures to that to make that make sense. Start the video again when you're done. Okay, here we go, writing our 4 statements. Write the if-then form, the converse, the inverse, and the contrapositive. So Olympians are athletes. So if-then form. If you are an Olympian, then you are an athlete. Decide whether each statement is true or false. Is this true? Sure. Okay, converse. Or backwards. So if you are an athlete, then you are an Olympian. True or false? Well, we have a lot of athletes in school, but we don't have any Olympians. So this statement is false because I can provide a counter example. Okay, inverse. Go back to the original statement and negate it. If you are not an Olympian, then you are not an athlete. What about this? That's false. Because someone at the school could be not an Olympian, but they could also be an athlete. You could be in basketball or football. Now, contrapositive is going back to the converse and negating it. So, if you are not an athlete, then you are not an Olympian. About this, that's true, because if you are not an athlete, you can't compete in the Olympics. Alright, next page. Okay. Now, up to this point, you might be saying, Mrs. Smith, this is really logic. It's not really geometry, because geometry is a math. But we can use all this logic in proving math statements. So here's the first one. Definition. If two lines intersect to form a what kind of angle? Then they're perpendicular lines? Right. The definition can also be written using the converse. If any two lines are perpendicular lines, then they intersect to form a right angle. You can also write line L is perpendicular to line M as L is perpendicular to M. Example 3. Use definitions. Decide whether each statement about the diagram is true. Explain your answer using the definitions you've learned. A to C, or line AC, is perpendicular to line BD. Is that true? Yes, the statement is true. The right angle symbol indicates that the lines intersect to form a right angle. So you can say the lines are perpendicular. Okay, AED and angle BEC are a linear pair. Is this true? No. So let's draw them out. Angle AED. AED. So this would be that angle here. And angle BEC, that angle. Are they a linear pair? Well, if you squish them together, they would make a straight line. But our linear pair definition says that they also have to be adjacent angles right next to each other. So they are not a linear pair. Example 4. Write a biconditional statement. Write the definition of parallel lines as a biconditional. If two lines lie in the same plane and do not intersect, then they are parallel. So, where's our solution? Okay, converse. So we're going to go backwards. If two lines are parallel, then they lie in the same plane and do not intersect. Okay, don't take shortcuts when you're writing these. And go ahead and write the words down. And I'm not meaning shortcuts like writing the number 2 instead of writing out TWO, but I don't want you to say something like parallel, then don't intersect. Okay, I want you to go ahead and write it out in words. So biconditional. So notice that we had to go from a converse first, and then to the biconditional. So if two lines, not if, just two lines, are parallel, if and only if they lie in the same plane and do not intersect. So biconditional, start with your converse and then go to biconditional. Okay, checkpoint. These are long, so give yourself some time to do them. And you really need to spend that time doing it, or you're not going to remember all this. So, I want to see these papers tomorrow, just because they are kind of long, and we need to make sure you know how to do them. So fill these in, and then bring it tomorrow.